Hello, everyone. What an energy. Hope you're all doing great. Thank you very much for coming out. I hope you're going to enjoy today's event. We did a lot of preparation to get you here. Hope you're going to have interesting takeaways and meaningful conversations today. So let's kick out a quick introduction from the meeting organizers. This is Budapest DevOps Meetup. You may or may not know, this group has been running for many years. We are still happy to see new faces coming out. We are still happy to organize. So it's a joint event organized by ICQ and my company, Epsilon Systems. We are also grateful for Cloudera for hosting an event and providing snacks and pizza and the place for discussion, and also providing us presenters. One of the presenters is Zoli, my ex-colleague here. I very trust his knowledge, and I'm very looking forward to his sharing today. Please enjoy his presentation, and then you can also reach out to him afterwards. He enjoys talking a lot, but in a good way. And also we have Zsolt here. I think we bumped into each other in meetups like this or the DockerCon itself, and we enjoyed discussions and collaboration ever since. So thank you very much, guys, for all the preparation you put into your presentation.
Yeah, thanks for having us, I think.
So this is all for now, and Zsolt is going to start his presentation about some of his new stuff. Keep in mind he actually just started the company with some other fellows only a couple of months ago. So anything that you see here is a little bit of cutting edge, but I hope there are going to be a lot of interesting bits. So in case the demo guts is not with us, don't worry. Just look at what he's trying to say. There are a lot of wise things inside. Okay, thank you.
Yeah, okay, thank you, Zsolt. Okay, so hi everyone. I'm Zsolt Varga, and I'm a CTO of Riptides. Previously, I was part of the Banza Cloud team up until the acquisition by Cisco. So after that, I spent several years at Cisco. And now we are starting a new journey with a new startup that is called Riptides. And basically, the topic that we are trying to tackle is how to manage workload to workload or service to service security, mainly from authentication and encryption perspective. Basically, the talk is about that topic in general, why we think there should be a new direction where we are going with the secret management and stuff. Okay, so yeah, very briefly what we are going to talk about today, but basically the non-human identities are what's the main problems with the management of those, how we think that an identity-first infrastructure level solution would be a better option here, and also there will be a demo, and obviously you will have time for questions at the end. Okay, so very quickly, what are non-human identities? So basically, this is I think the non-human identities term itself is quite new, or I don't know how many of you heard of us, heard of the non-human identity as a term? Okay, Sam? So, well, it's just basically a fancy name for credentials. So the identity itself is a bit overstated here. But the idea is that it refers to any kind of data, let's say credentials, that are used to between two workloads to authenticate one another. And as you see here, there are obviously, as you may be well aware of that, there are several different kind of credentials or non-human identities. There are just some listed here, like service accounts, API keys, So basically, any kind of data that the workload can use to prove its identity or prove its access, or basically authenticate towards another workload. That's what it is. And why is it important is because of the diagram, you can see that, lately there was a huge jump. So maybe there are 40, 50 times non-human identities, there are human identities. And on the human identity space, you may be also well aware of that. There are Okta and Auth0 and a bunch of other solutions, and also quite a good number of well thought out processes to handle human identities. But that's not so the case with non-human ones, and basically this is much more fragmented. So the importance, obviously, is that are there any risk with non-human identities? And basically, these are just some examples that usually got leaked somehow. That's one of the main problems with them, or mishandling those. And this is obviously a huge risk, and it's not just about some developer in a small company maybe just forget something or push it into a repo or commit it into a repository and then push it to GitHub or whatever. But obviously it happens really to the best of us as well. So lately there were a lot of news about attacks that involved non-human identities, basically leaked credentials that led to a bigger scale of issues. So this is just highlights the importance of the fact that we have to take care of that. And what's the problem there? So the problem is that there are several issues with it. One is that if you think about it, how we handle these, first and foremost, the internal and let's say third-party wise, they are usually managed totally differently. So there is a fragmentation problem there by that comparison. So I mean, generally the internal security of a company infrastructure is that's my experience, that usually it's much worse than towards third parties. Why? Because towards third parties, the third party side forces you to use encryption, to use authentication, use tokens, rotate them. So there are issues how to do that, but at least it's forced by the third party. For internal communication, obviously the company is on the both sides of the equation. So the problem is that if you don't enforce yourself to do something, you don't need to do it. So that's why usually the internal infrastructure should, I mean, we talked to several companies, and a bunch of those just say that, well, yeah, internally, and any service can communicate to any other service. That's not an issue, or they don't handle that. But even if they do, that usually handled and managed differently by team, differently by part of the organization, again, internal, external. And what the problem is that there are secrets all over the place. On the other hand, if the management of those secrets and credentials are semi-automatic or involves manual processes, that tends to mean that those going to be more broad in access permissions, not rotated, and not going to be long-lived, because rotating them and creating a new credential and distributing them obviously takes time and effort. Can break things, so not to touch it, things like that. So that all comes and adds together. Is that the other thing is that so the credential management also involves the developers a lot, and by that I mean the developers directly have to handle the credentials, right? So in some sense they have to handle the part that within the companies with various processes, how to get a credential or manage it in a way that the developed application is able to use it. So a bunch of hassle with that. And usually the solutions that are there are running also in the user space, which is a pretty crowded layer within the infrastructure. So all of this adds up to, I think it needs a different kind of view how to handle these. And so what our idea is that instead of handling these via various methods, why not just create a separate layer within the infrastructure to handle all of these things, right? So the idea here is that instead of having to have different kind of credentials all over the place, which are, which the correlation between a particular service and a particular credential is just implicit at best. So it's not like the credential is tightly coupled with a particular application, but rather it's created how it is created, and the best case there is a note about what services it relates to or something like that. So instead of that, we think that the foundation of the authentication of different workloads towards each other should be based on identities of the workloads itself, and basically all the authentication and the necessary credentials gonna be tied together with that identity, and then basically moves wherever the application moves within the infrastructure. And the other thing is that we think that it should be done just within the Linux kernel, in Linux at least. Why? Well, there are several reasons. I'm going to talk about that as well in a short time. So yeah, so basically the fabric just, as you can see, one important thing here is that the Linux kernel and by that the identity fabric is just between the application layer and the network layer, and so that means it's transparent to the either side. So it's not like it's not a network solution like Cilium, for example, and also it should be as transparent to the application as possible. So that's the gist of the idea. Okay, and how many of you guys heard about SPIFFE or SPIFFE ID? Okay, not that many. So the idea here is that the SPIFFE is an open standardized identity format, or you can say framework. So the idea here is that in order to have federated trust between various organizations, there has to be some kind of a common identity format in order to be able to work with each other. So the idea here is that, let's say, you have a SPIFFE identity within your own internal organization, and then you can federate, let's say, with AWS, and at AWS you can use the same identities as the basis of the access management there. So instead of saying that, let's say you have a particular SPIFFE ID within your organization, and then at AWS there is an RN prefixed identity or whatever AWS specific construct. Instead of that, you would be able to use the same exact identity at AWS. So that was the main problem, and that's what this SPIFFE is trying to solve here. So basically, it's pretty simple format. It's very similar to a URL, but the scheme is SPIFFE, as you can see there, and then there is the domain part. They call it the trust domain. So that just means that within a particular trust domain, this is a management domain where the authentication is managed at one. So basically, it's uniquely identify a particular something within that trust domain. So it should be unique, obviously. And the path itself, that is the identity of the workload, that is it's not specified how it should look like. So you are pretty much free to come up with anything. I just put an example there. It's like a web front end within the pod environment. The SPIFFE idea, which should be something like this. And why I'm talking about this is because within the solution that we are working on, we are going to identify the workloads with these SPIFFE IDs. And as I said, it's standard, so it's interoperable. That's why it's very good. And again, just quick summarization here. So why the Linux kernel? Okay, so there are several reasons for that. One is that obviously, in order to have very strict identities about the processes that are running on a particular node, the kernel is the most secure place in order to get trusted information about a particular process. And also, that means that, as I said and shown on the diagram before, it makes the whole management of the authentication and the encryption highly transparent to the developers. So that's another, I think, vision perspective, is that I think the identity management and basically the authentication and the credentials, I think it should work like the network. So if you think about the network, the application developer rarely cares about the network, right? So the application, you just assume that when an application is running somewhere, it's going to be able to connect to whatever service it needs to connect to. The developer doesn't handle that, the network aspect of the whole thing. And similarly, I think the authentication should be very, very similar to that. So instead of handling the credentials directly, all the developers should care about is that describe the intent itself. So it's like, hey, I have an application and that application needs to access that resource or this resource. So like, I need to talk to OpenAI, so I need to have obviously access to that. And this is the only thing that the developer should describe and transfer the information to the whatever part of the organization that handles that identity fabric, and that they can configure that, hey, okay, this application should be able to access, so we're going to provide a key for that. And the application developer doesn't have to handle the credential directly. And also there are performance perspectives as well. So what we are doing is that within the Linux kernel, we create TLS connections to the other side. So that means that basically all the encryption, authentication, and cert management and everything else happens within the kernel. I will show it in the demo. But the idea there is that obviously within the kernel we can use KTLS, for example. That is a built-in TLS support within the kernel, but it just handles the part after the TLS handshake. So we had to do the TLS handshake by ourselves. And so the other thing is that the Linux kernel makes it very platform independent, this whole solution. So what that means is that it doesn't really matter whether the application is running, within a Docker container, directly on the node, in a Kubernetes pod, or wherever. From the kernel's perspective, it's just a process. Obviously, it has some characteristics like what C groups it resides in, what namespaces it has, something like that. But from the kernel perspective, it's just a process. And so it makes it platform independent. And obviously, we will integrate, and the solution can integrate with the platforms, but it doesn't depend on the platform itself. And the other thing is that the user space is very, very crowded if you think about it. So there are lots of infrastructure-like components within the user space, just because it's easier to, at least at first, it seems like easier to handle that there. But that means that you have a bunch of proxies and all other similar concepts all over the place. That means that from deployment and management or operational perspective, there are lots of issues that we need to tackle. And there are also ownership problems as well. When by ownership, I mean, if you, let's say, deploy an application within your Kubernetes cluster, and let's say there is a proxy-based whatever in front of your workload. Now, if something happens, who's going to handle the issue? The developer, the DevOps guy, the guys who handle, let's say, the service mesh or whatever. So there are these problems as well. And by putting it into Linux kernel, it creates a very clear ownership about who handles that part of the infrastructure. Okay, and very quickly, so how to define an identity? I put there a simple example there. So basically, as I said, the idea here is that every identity that is related to a particular process is based on the information, first and foremost, that we gather from the Linux kernel. And obviously, the basis of the whole thing is a process ID. And based on the process ID and various other information that we gather from the kernel, we get some basic information about the process. And after that, there is an agent in the user space in each node that basically gathers a bunch of other metadata in relation to that particular process. And then what you can do is specify what kind of metadata describes a particular process, right? So as you can see here, this is an actual working example. So you can specify that if a particular process have these metadata, so it's like running in this Kubernetes container with this node, et cetera, then this process should be identified as external secrets operator, right? And after that, the whole thing is handled, transparently to the application. Okay, some deep dive into, how it looks like. So basically, what you see here is the basic architecture of what happens under the hood. I don't want to go that much details unless you are, keen to do that. But the idea I was talking about is represented here. So basically, but you see two nodes. Basically, there is a user space agent component, driver. Driver is basically a kernel module. And then whenever a socket communicates to another socket, that's where we kick in. So that's why it's a network independent or transparent to the network, because we don't care how those sockets are created or how the network operates. But as long as there is connection between two sockets, then that's where the solution kicks in. And basically, based on those informations and identity definitions that I've shown, it determined whether this particular connection, in relation to that connection, what kind of identity one socket has to have, what kind of identity other has to have, and we create a TLS connection just within the Linux kernel between those two. And we also can handle minimal authorization settings there. So it's like what ID is able to connect or talk to what other ID and whatnot. But I will show it in the demo in a few minutes. So yeah, it's pretty low level, but but that makes it very, very powerful. And what you see here is basically mainly the internal part, or I mean the internal infrastructure related part of the solution, because here is no third party involved, and by third party I mean some other service that is external to your company. But the solution itself gives some options towards third parties as well. So in this diagram, what you can see, and I also show it in the demo and explain it as well there, is that based on that identity, you can specify that what kind of credentials a particular workload or identity should have in order to operate. And so in the demo, what I will show, for example, is that in order to create, let's say, credentials that is necessary for a workload, there can be various providers that can do that for you. It's not part of the solution directly. But what happens here is that there is a credential provider, and that credential provider is able to communicate to a control plane without any real credentials. And it will be much more understandable in the demo. But the idea here is that, let's say, you can run a workload that can, let's say, access GitHub repositories without any credential in the user space whatsoever, right? So that's the whole idea. And the other thing is that it's managed by that particular identity fabric. So whenever I say that access is revoked, the access will be, get rid of, and the access will be denied. Okay. Okay, demo time. So let me sit down because it will be easier that way. Okay, share the whole screen because it will be. I have just one hand because I have to hold the mic in the other. But okay, no, it's fine. But thank you. Yeah, thanks. So okay, so what you see here, I will demonstrate. Is it big enough? Or yeah, okay. Let's make it. Yeah. That's what she said. Yes. Okay. So I make it a bit bigger. Okay. So what you see basically just 3 terminals. So in the first terminal, I'm just doing an ngrep just to show what's happening on the wire. Basically, there is an Nginx server that is running on. These are 2 Lima nodes on my notebook, so nothing fancy here, but it could be any node anywhere. And what happens is that if I start the ngrep. If I do a curl, just on the wrong interface. So I do a curl, nothing fancy, it's totally plain text. There is a GET request, a response, and that's it. Okay, and if let's say we introduce some of the concepts here that I was talking about. So let's say so on the control plane, there are these resources that you can use. We are using standard Kubernetes API server. Okay, so the control plane itself is not running on Kubernetes, but the control plane speaks Kubernetes. Let's just put it that way. And so in order to secure that communication that you've seen before was totally plain text on a particular node, there are no containers there, no proxies, nothing whatsoever, just a node. If you define a particular identity, that means that if there's a process that is the name is Nginx and the process UID is 33, then it should assign this prod service Nginx. Okay, so let's see what happens if I apply this. Okay, and let's go back to the terminal. Okay, what happened is that it doesn't work anymore, unfortunately. Why is it not working? Because now the Nginx part is secured, right? So by that definition, I applied the definition, and it was, went through the kernel on that particular node. And so if I just create an OpenSSL connection just to see if there are, something there, and you can see that there is a certificate in front of the Nginx, right? But it's not, managed or configured by Nginx. It was all happened within the Linux kernel, right? So, and because of that, obviously, the other side cannot talk to it anymore, right? So how can we fix that? We can fix that by issuing an identity for that curl process as well, right? So there is another identity definition, and you can apply the definition, and then what happens is that boom, it works, right? And if you see in the ngrep, it's fully encrypted, right? So we were able to secure on a node the directly running Nginx just by defining these identities, and every encryption and the TLS connection itself happened within the kernel. Right? Yeah. Well, it's using HTTP, yes. And so that's one part of it. And the second thing I'd like to show here is that, as I said, we can even do some authorizations here. So we can say that, let's say, if I apply a bit differently from the Nginx side and say that it's only these PFIDs allow it to talk to it, then this curl doesn't work anymore. Why? Because the identity of the curl is not matching the allowed identities. If I allow it, because this is the identity of that particular process, oops, sorry. So if I apply this and basically allow the communication to go through, it's going to work again, right? So it's like magic. Okay, so that's one part of the thing. Now the second situation. Now, very quickly. So what happens there is that let's say we want to communicate towards a third party, right? So we're going to use a simple GitHub CLI to do that, hopefully. Okay, so let me just check what we have here. And that's fine. Okay, so let's just try to have that. Okay, so in order to communicate to GitHub, we have the GitHub CLI tool, and for the GitHub CLI tool, we can specify a token. Yeah, bigger. Okay, I make this bigger as well, and the other thing is bigger. Okay, so basically more. Nothing is enough. Okay, is better. Okay, so what happens here is that again in the user space. Oh, sorry. In the user space, there are now a token that is available within that particular file. The kernel basically put it there into that file. And what's important about that particular, so how does that work? There is another resource there that's called workload credentials right now. And what it specifies that for a particular workload identity, I want a token to be available, right? And that token is exactly what's within that particular file. But the important thing here is that if I go, let's say if I'm root and I want to, I don't know why. If I want to, let's say, see what's in that file, okay, I'm not allowed to read it, right? Even if I'm root. It's from permission perspective, that's fine. Everybody can read it. But within the kernel, we enforce who actually is able to read the content of that particular file. So by the definition of workload identities and the definition of the credentials that are allowed to be accessed by the particular identity, that is handled, let's say, transparently. So why the cat command also within root it doesn't work, but if I do it with my own user ID, it's going to work because that's also allowed within that identity. I just show you in a minute, in a second. So if we check the identity, sorry, if we check the identity, right? I just put the cat there in order just to show you guys that what actually that file contains. And what's important, and also important here, I'm not sure, I think it relatively frequent, it changes, but the other thing here is that it gets rotated all the time based on configuration. So the token within that file is going to change, you know, any time, you know, whenever that is, however it is configured. Okay, and you know, that's just one thing. So you can read it from a file if you want to. I mean, your application is able to read it if you want it to. But the other thing that we can do through the Linux kernel is to basically don't even have to do that and just put it onto the wire. Now there are several, you know, so I'm just giving you options, you know, what you can do with a similar solution like this. So basically, oops, if I configure the GitHub as a particular service, then I can specify within that identity that I would like to have that credential basically put it onto the wire. That's what we specify here. So what we can do is launch another command, right? Hopefully this will work. Okay. So what happened is that I get the repo list, but it's not read from the token. It's not read from any file. It's just transparently we put it onto the wire real time, right? So whenever that particular repo command or API call is getting to GitHub, we, you know, hijack it within the kernel and then put the necessary headers that are needed. And this is also obviously rotated. So I'm not sure if we check the file again, it's changed or not, whatever. So we can do that as well. And another even more fancier way is that because you can say here that obviously in order to do that, you have to have an HTTP request as Lajos mentioned in the previous example. Why? Because in order to manipulate that packet, it has to be plain text, right? Because if it's encrypted, we cannot, put anything into it. So it has to, not has to, that's what I'm going to show you, but the easier way is that you are able to configure the URL. That's the easier way to go. But obviously there are also another way. So we can even say to configure something else here, and if it's right, yeah, it still goes through, right? So right now it does an HTTPS request towards GitHub, but we basically do manage the middle within the kernel, and then also put the credential onto the wire. So the whole thing that I'm trying to demonstrate here is that the whole idea is that that repo, that token that is necessary for that application to communicate and authenticate towards GitHub is not in user space, not in anywhere, and wherever within your infrastructure that particular application arises, is going to be able to reach and able to get the necessary credentials and access than it was designed to do, right? So that's the important factor here. So yeah, I think that's it from demo perspective. That's what I wanted to show you guys today. It worked. Thank you. Okay, and yeah, if you have any questions, please feel free to ask. Yes. No. The reason is that environment variables are user space concepts. So from within the Linux kernel, it's not accessible because the environment variables basically only resides in the user space memory of a particular process. So from the kernel, it's not available. I mean, we have some ideas around that, but it's rather hacky. Let's just put it that way. So there's not something that we support probably tomorrow.
So you mentioned that this would be easier to handle because, well, in the beginning of your talk, you're saying too many secrets. So now will you have too many workload identities with fine-grained control over processes and accesses and whatnot?
Yeah, but the thing is that the workload identity is much more, easier to handle in a sense that, if you have a bunch of workloads all over the place, you have to define the identity just once. So wherever that application pops up, every credential and everything else follows with it. So if I would, let's say there are, 100 nodes or whatever, if I configure that, let's say for my user ID with this particular application, I would be able to access this or that. Whichever node I'm logging into is going to work without any, operational burden on that. So there is no, besides the kernel module and the agent, there is no other, management necessary in order to put those credentials all over the place.
So any dev cluster that pops up will need to have that custom kernel module that will need to reach the environment where the actual credentials sit.
Yes. So basically, in order for this to work, you have to put a kernel module in place, and you have to put an agent onto the node. But think of it like a very, security infrastructure dependent something. So it's like a kubelet or whatever. So it's not something that you should install to Kubernetes, let's say, but rather it should be sit on the node, because from security perspective, it's a better way to do that way. But yeah, right. So in order for this to work on every node, you have to have that kernel module in place. But the thing is that it's not, as I tried to demonstrate, it's not platform dependent or application dependent, because it uses, simple concepts which are generic. Mm-hmm. So, but yeah, so the idea here is that, the idea here is that first, I didn't talk about this, but so where we think the whole industry is going, and I think it will help us along the way, is that instead of having to have credentials for the various different kind of credentials for various different kind of infrastructures and third parties, with the SPIFFE ID and the SPIFFE Federation, you will be able to, without direct opaque credentials, communicate to AWS and Azure and whatever. But until that point, we wanted to provide a way in order to, let's say, broker credentials in your name. But the idea here is that the credential, as I said, it's directly tied within the application. So if I would remove the secret that contains that credential, all the application lose access instantaneously. Right? So
you're preaching to the choir. We're in the business of putting both like session only tokens or authentication. So as soon as your session or pod is gone, then the access is gone. Oh yeah, nice.
Yeah, and one another aspect I didn't talk about, I just want to mention is that, so how the credential pops up within control plane is that there is a K3S that is running on one of the nodes, and within that K3S there is an external secrets operator that is running, and the external secrets operator basically creates a GitHub credential, and then it puts into our control plane, because I said it's fixed Kubernetes. That's one thing, and the other thing is the external secrets operator itself doesn't have any credentials to the control plane, right? So it authenticates to the control plane via this kernel solution that I showed.
Cool.
Yeah, sure. Okay.
Just a second.
So a bit related to the previous one. So why did you choose to use a dedicated bespoke kernel module instead of using eBPF?
Yeah, the reason for that is relatively simple, because eBPF cannot do what we want to do here. So what we are doing is we are doing TLS handshake within the kernel. That means that it needs a lot of cryptographic and mathematical stuff to do within the kernel, and eBPF is just not capable to do that. So that's the the main reason. So eBPF is just not good enough in order to handle what we need here. But it's a good. I mean, we get this question a lot. we actually talked to the Cilium guys directly about this, and so they are also trying to tackle similar problems, and they said that they cannot do it within eBPF as well. Sorry? Because eBPF eBPF is pretty limited. So basically, you are not able to do that kind of calculations with eBPF, because the eBPF, I don't know what it's called, the eBPF, I don't know, that runs the code within the eBPF code within the kernel. It's just limited. It's not Turing complete, and it's just not good enough for these kind of purposes. That's the reason. So that's why we have to go with a full-fledged kernel module, at least right now. Obviously, we are constantly on this issue. So if the technology changes there, and the eBPF will be able to handle these more complex functions that we need to have there, then yeah, we're going to do that way.
Any more questions from the back? I know Zoli is trying to ask. Any question from here now? I'm gonna give the mic to Zoli, of course.
So I'm gonna put you on the spot a little bit. So you had the diagram at the beginning of the presentation about the non-human identities slowly, exponentially outnumbering the human identities. So it's a great thing that you are trying to eliminate the static aspect of the identities, like the static secrets and sharing of that.
Okay.
But aren't you worried about because of so many identities, the chance of misconfiguration, even if a small one, because it's such orders of magnitude higher number of connections, that that's going to be your next problem, and you're switching one problem for another. And how would you deal with that problem of now your problem being misconfigured trust relationships instead of leaked secrets?
Yeah, I mean, that's a fair question. And I think, somewhat of, general problem with the progress of technology. So there are always, pros and cons about these ideas. We think that, so the management of those identities is not meant to be all over the place as opposed to credentials, right? So as I said, it's much more, tight who are going to manage those credentials. So very, very simply, there will be a team who actually managing the security aspects of the whole infrastructure. So it's in their hands. So it's obviously it's still an issue, but how we can manage that is that you obviously to the product we are going to have a bunch of helpers to avoid that particular issue or this particular issue. But generally, the risk is there. It's kind of, it's like if you have firewalls and you misconfigure a firewall, then you have an issue. So it's not something that we are, tackle all at once. But really, the important thing here is that right now, if you create a credential, that credential, as I said, very rarely tightly coupled with an application, and also generally replayable, right? So you don't even know if it get lost, right? Because it's just, everyone can use it if the network access is there for a third party, let's say. But here, every credential, even if it's the same, let's say, OpenAI credential, which is a token in OpenAI, but it's directly managed and tightly coupled with an identity. So if you deny that access, the credential will vanish, and you know what happened there and what credential is created to which particular identity.
So why I was asking that is because I do wonder whether introducing some level of observability, besides configuring the trust relationship, also having some observability about checking my assumptions that they are actually right.
Yeah, I mean, yeah, obviously there are a bunch of other aspects of what we are building, that are there. Observability is one of those things. So obviously within the kernel, we have network level observability, and we're going to provide observability within the product itself. And by the way, the kernel module, the plan is to open source the kernel module. So there will be an open source version of this that is available to use, or there will be when we get there. But so the idea here is that, yes, we're going to provide observability, but this will be strictly security-related observability. So we are not keen to, provide any kind of, let's say, more operational like observability, but purely network security related. Yep. But I'm going to be here. Okay, so we can either we have more questions or ideas or whatever. I'm really glad to hear that. So basically, first of all, thanks for having me and I have the opportunity to show you what we are working on. Really, the main reason for this talk is to give you guys an idea what we are cooking, what we are working on, and I'm really curious about these questions are really great. And if everyone has any questions or something that bothers you or amazes you, whatever with this technology, I'm happy to hear them. I'm going to be here after the second talk as well.
Yeah, cool. Thank you very much for spending
Thank you.
your night times preparing for presentation. Also, good luck with your new company. I hope
Thank you.
you're gonna be successful. And yeah, please give us some updates later on the road. And then Joe's gonna be staying around afterwards. So if you have any opinion or questions, he's actually here to learn and answer the questions. So there is a learning process.
Sure.
Inside. Thank you.
Thank you. Thank you, guys.
And now we're gonna quickly swap out the laptops. Zoli prepared some demonstration. Probably he was also gonna introduce his topic, like what Renovate is trying to solve. So Zoli works here at Cloudera. He used to be my colleague. Yeah, he's a tool guy. He likes security. He has 3 kids. Yeah, so please give it up for Zoli.
Okay, so welcome. So this session is going to be about a tool called Renovate. And I hope everybody at the end of the session will say no to perpetually outdated dependencies. We will dig into what Renovate is and what it is actually used for. So Renovate is a dependency update tool. It supports like a lot of dependency management tools or package managers out of the box. It's also extensible. So that means if you have your own special Snowflake homegrown dependency update tool, you can most likely integrate it with Renovate, which you cannot really say about Dependabot. I'm going to shit on Dependabot a lot in this talk. So basically, any kind of custom version management is no challenge to Renovate, in my opinion. So why would you use Renovate? Because most software has dependencies, except for like the very basic ones, like left pad that, let's say, caused some ruckus like 10 years ago. So those dependencies usually get periodic updates. So then, like that software can be a CLI tool, a Docker image, a Helm chart, NPM package, Maven package, etc. Pick your poison, basically. And most software has bugs. I still have to see software that doesn't really have bugs and is actually practically usable software. Like there are some theorem provers and theorem software that mathematically speaking is flawless, but it's not really that useful. So these bugs a lot of the times become gateways to security issues as well. So dependency updates in the current day and age is a lot of times related to the security aspect of software development. Basically, nobody really can get away with not updating their dependencies in this day and age. So how do you solve this problem? Like, number one, simplest solution, you take the latest version, you take the latest tag, whatever you pin, you always pick up the latest release. And then you get another problem then. You lose any chance of having reproducible builds. So what are reproducible builds? Essentially, reproducible builds are, again, mathematically speaking, it's kind of a pure function that we are talking about. All of your inputs are captured and the output is always going to be the same. Why is it reproducible builds important? Because if somebody builds software and then it has a binary artifact and you hash it, basically you get a fingerprint of it, and then you want to make sure that it was actually built from the source that you assume it was built from. If I build it on my own machine, I can reproduce it to have the exact same fingerprint. So it's sort of like a trust issue that independent parties can validate that the build software came from the actual input. So this is why reproducible builds are important. So pinning to latest, not advised. It actually makes things way more obscure. But then that means we need to start pinning dependencies. And with pinning dependencies, a lot of work comes. So that means, okay, now you need to create a calendar entry for every Monday every first Monday of every month, where you go to NPM, you go to Maven Central, you go to Docker Hub, check whether there was an update of your dependencies, and then you create the pull requests, and then you seek approval for the pull requests, and it's just a chore. It's very annoying. Nobody really wants to do that. So technically, Renovate was born out of the need to reduce that toil. Dependabot was also born out of the need to reduce that toil. So it's a tool that can manage the lookup of the dependencies versions, and then it can also patch your source code, and then submit pull requests in GitHub, GitLab, Bitbucket. Source path is not supported yet because it's email based. But what's the other stuff called? Code Forge.ho. I don't know. Like that's also supported. So like even the less commonly used source code platforms are supported that are Git based basically. I'm not sure whether it supports older SCMs like I don't know, CVS. So why not Dependabot? Why are we not gonna use Dependabot? Like number one, I wanted to say like Renovate is self-hosted, so you can, if you're that kind of guy, you can self-host it, or like if you are in a big bank or whatever, you're not allowed to use like a publicly hosted third-party application, so you need to self-host. But turns out Dependabot also supports self-hosting now. So, but there's still some really good points on using Renovate other than self-hosting, and that is that Dependabot is not really extensible, and it has a way more limited number of package managers that it supports. So I made a list of what package managers Renovate supports and Dependabot doesn't support. So if you're using Bazel, you're shit out of luck with Dependabot, doesn't support it. Elixir, any Elixir project, nope. Haskell, nope. If you want to patch Docker images in your Helm values files, nope. If you're using Puppet, still, you have no chance of patching that with Dependabot. Same with if you are wrapping your Terraform with TerraGrunt, now you're shit out of luck with Dependabot. If you're using Scala and manage your packages with SBT, Dependabot doesn't want to have anything to do with you because you're a niche. Leiningen with Clojure, not supported. Nix Flakes, if you're a Nix fan, not supported. And a big variety of CI tools that are not GitHub Actions, not supported. And Renovate supports all of those. So it's for the small guy who is brave enough to pick the niche technology, who's brave enough to not care about everybody using React and everybody using JavaScript. They are gonna go for, I don't know, Elixir and the Phoenix framework because that's just awesome. And why wouldn't you do that? Just because HR tells you they cannot hire Elixir developers. And Renovate also has a much more extensive configuration support compared to Dependabot. So how do you use Renovate? So Renovate is like a batch job. It's a CLI written in TypeScript. So it's basically you install it with pnpm install, and then you run it on the CLI. You give it your GitHub token, and it opens the pull request. That's the simplest way. You don't need to have servers running anything. You can just start running it locally, and then it opens the pull requests with your user ID. And then, if you want to make it more permanent and not just test driving it, then the next easiest way is to put it into a GitHub action, and then run it on a cron schedule, or even through a simple workflow dispatch where you click a button, it runs the GitHub action, or both. And then otherwise, like if you have Kubernetes, you can run it in a Kubernetes cron job. It's fairly trivial to run, I think. So basically, the philosophy here is Renovate makes the updates easier. You don't need to hunt down the versions. It opens the pull request even before you become aware that there's a security incident happening. You already, by the time you read in the news, you go to your GitHub repo, there's a pull request, bam, merge, trigger the release build. So they are following a philosophy that says integrate early, integrate often, some small thing called continuous integration. that everybody's supposed to be following the past, like, I don't know, 15, 20 years, but not really. So their philosophy says you regularly integrate the updates, because if there's breakage, it's always better to fix a small breakage than update the dependencies every 5 months, and then you have a ton of breakages that you have to fix at once. And boom, CV comes, and the fix is obviously not gonna be released in a hotfix branch, because most open source projects don't maintain hotfix branches. They only have a single release branch. So you get the CV fix with the release that also has the feature releases. So it makes sense to integrate these updates early and often, because that's simply the reality what we have today. You cannot escape that. So smaller updates, less painful. If you have to choose between less pain and more pain, you choose less pain. You cannot choose no pain. So Renovate allows you to at least make this as simple as possible. Like if you're more paranoid, you get a pull request that you have to click merge on. And if you're less paranoid, you can have it auto merge the updates if they are, let's say, minor updates or non-breaking changes, if you can trust the vendor to what they say is non-breaking is actually non-breaking. So the very simplistic model, like, don't expect much. So Renovate goes out to the source code manager, pulls down the source, parses the source, discovers dependencies, then goes out to the dependency data source for all of the versions, fetches all of the versions, and then technically it sorts the versions, removes versions that you don't want to have. Like you can filter out like major updates. You say, I don't want major updates. I only want the patch and the minor version bumps, and then it patches with the biggest number that remains. So Renovate has 4 key concepts. So number 1, platforms. This is responsible for fetching the source and then opening the pull request. So platforms like GitHub, GitLab, Bitbucket, ForgeHo, and I don't know what else. Like there's, I don't know, like 5, 6 of them that it supports. The other concept is managers. So these are modules that are aware of, let's say, more high-level semantics, like, oh, this is an npm package JSON file. I need to go to npm.js as a data source to fetch the versions. It follows Semver coerced versioning strategy, etc., etc. And it knows how to patch your package file. So such managers are like, you have Node.js, you have Go modules, you have Nix flakes, as I mentioned earlier. So the usual package managers, and then you also have an option to define your custom package manager. I'm gonna demo an example for that. So I also mentioned data sources with the managers. So data sources can be like Docker Hub or any kind of OCI registry, NPM, I don't know, like all of the stuff that where you can find your software versions. And here, Renovate also gives you extensibility, bringing in custom data sources. For example, I was writing a custom data source for Firefox versions, because in one of our Arcane systems, we are installing Firefox Debian packages that we download from the official Firefox website. And then Firefox publishes their versions in a neat JSON format. So you can write a custom data source that fetches the Firefox releases from the Firefox website, and then you can extract the list of versions. And then from that point on, the other plumbing takes over. Versioning strategies, sorting, picking out, limiting what versions I'm gonna allow. So, and the 4th pillar is the versioning. So Renovate supports, I don't know, like maybe 50 different versioning schemes out of the box. So basically you have the Python versioning schemes, you have the regular assembler, you have, I don't know, a ton of versioning schemes for different software ecosystems. And then this also allows customization and bringing your own versioning scheme. The only limitation is your versioning scheme has to be able to map to Semver at the end. So like if you have a versioning scheme that has, I don't know, maybe I'm gonna write an example a bit later. So like it's 1.2.3-R5- dash and a timestamp that can be mapped to Semver, essentially. You just need to define how it can extract the various different parts from the version, which is the revision, which is the build number, and then it can deal with it and sort it. Basically, the sorting is not even relevant, by the way. That's a secret. So some cases like AWS AMIs, where you update AMIs with Renovate, there is no version. There's AMI IDs, and it's only relevant what the latest one is that are build pushed. So I'm gonna stop talking very soon now. So you can see like Renovate, pretty steady growth, about, I don't know, 18,000 GitHub stars now. So it's not bought stars, I'd say, because then it would be like skyrocketing immediately. So it has a pretty steady growth over the years. It's getting more and more popular. Some examples on which projects are already using Renovate. Like there are some of them, the more mainstream JavaScript frameworks for the front end, like Angular and Vue. JavaScript, most popular JavaScript server backend, Nest.js. Most popular JavaScript test frame for Jest also uses Renovate to patch its dependencies. Then you have the love child of Python and Rust, UV and Rough, the newest kids on the block that is basically, I don't know, dominating the Python landscape like a storm. Those are also using Renovate now to manage their dependencies, their Rust dependencies. And then in the Kubernetes space, Cilium is one of the projects that's using Renovate to patch its dependencies. Crossplane, basically that whole containers org in GitHub, which is technically a code word for Red Hat. They are all using it. Hatscale, which is a self-hosted version of Tailscale, coordination server also uses it, and then the Mastodon server. So I just picked these as like fun examples of like the Renovate being also used in the mainstream. So I'm gonna demo. I'm just gonna show a couple of pull requests. So that's gonna be a difficult demo, but still, please take off your shirts and pray to the demo gods. Just kidding. Okay. I don't pray to the demo god, he prays to me. Yeah, I'm jinxing it, right? So one example here I picked is it's Rancher, how Rancher is using Renovate. This is an interesting example because it shows one of the interesting aspects of Renovate, which is config reuse. So like I'm not gonna go deep into how the Renovate config works with this example, but basically it's like a JSON-based config format, and you have a way of sharing config across repos with this so-called shareable config, I think. I don't know how they call it. And like you can see, it says it's under GitHub in the Rancher org in Renovate config. And then if we look at it over here, 1 second, going up. And then basically here's a ton of configuration for their weird edge cases and groupings and whatever. And then they can share this configuration in all of their repos. So you don't need to copy paste the Renovate repo across your organization to every single repo. It has this nice feature. So another one, not this one, 1 second. So another one, I picked this pull request as an example in Cilium. Like I zoomed in too much, so it looks a bit weird. Anyway, so what's interesting here is like this is a regular renovate use case where it's just patching. Yeah, I jinxed it, right? I cannot click the link. Okay, so interesting thing here is, so it's patching not a Docker from part, but an arg in a Docker file. Like Dependabot cannot deal with this, but Renovate can if you define a custom manager for it. So I'm gonna show the custom manager in a second. So the interesting thing here is, you don't be too scared about it, but this is regex based. They already have something that's non-regex based, by the way. Let me find it 1 second. It's actually, zoom in 1 sec. Okay, I cannot find this custom manager, so I'm gonna show it in my own own example. So one of the custom, how a custom manager works, like in this example, I'm having I don't know, an OpenTofu version file, which is used by a CLI called tn to switch between versions of OpenTofu or Terraform, and then you pin the version of OpenTofu with this version file. Renovate doesn't support patching this out of the box, but thankfully, because it has this custom manager support, it's relatively trivial by adding such a block. Okay. So adding such a block that says custom manager, it says, oh, this is a regex manager. There's a description. It says any file that is OpenTofu version, just match that single line. You have to use a capture group that says this is the current version. And then you say, its data source is GitHub releases. So it's going to look at the GitHub releases to get the versions. You are going to say the package name is OpenTofu/OpenTofu. So it's going to go to GitHub OpenTofu/OpenTofu to look at the releases. And that name means I just want to configure Renovate to call this dependency OpenTofu. And by having this block here, instructs Renovate to then patch that OpenTofu version file, which then results in such a pull request over here, where it says, okay, I'm going to patch OpenTofu from 1.90 to 1.91 because it's a GitHub release. This is strictly limited to GitHub releases today. It can inline the release notes for your update. So you have everything collected in the pull request to review the update. And then the nice thing is, because it's a pull request, like if you have other validating GitHub actions or other CI jobs, it can validate it and then greenlight it if the builds are passing, etc. And then you can see like the diff is just, yep, it's patching the version. Another example here I brought was updating Terraform providers. So in this case, I was using a GitHub provider. So I was creating a GitHub repo with Terraform. I was using the 6.5.0 version, and there's a newer version that you recognized it has. Like you can see here, there are no release notes because it's looking at their Terraform registry. Actually not. Actually, it's looking at the OpenTofu registry. I'm going to show you in a moment how that looks in a configuration. So you can see here, there was a pin to 6.5.0 and then patched it to 6.6.0. And then the nice thing is it's also running the log file update. So the Terraform log also gets updated. So going back to the security aspects, like this is a very big deal when it comes to supply chain security to actually lock your dependencies. So going back, So going back to the configuration. So you can see here that in this case, like by default, Renovate is gonna go to the Terraform registry, but let's say you decided, okay, I'm gonna ditch Terraform, I'm gonna migrate to OpenTofu. And then you basically need to have such a so-called package rule that says whenever it goes out to look for Terraform providers or Terraform modules, it should go to the OpenTofu registry instead. And then that means it's gonna scrape the versions from the OpenTofu registry for the Terraform code instead of the Terraform registry. And if you have mixed code, these package rules can also be defined with file path patterns, like be it regex or glob pattern, where you say some of my code base has not migrated yet from Terraform, but this already has. So for these, please use the OpenTofu registry, and for the other, still look into the Terraform registry. Yeah, and then the final example I have is a custom versioning scheme. So let's say you have a monorepo where you put everything. You put not monorepo is not a good example. Let's say you just have multiple Terraform modules in a single repo, like hundreds, and then you want to release them. So you have a versioning scheme where, because it's a single repo and you still want to use tags, you're going to prefix the tag with the module name. Okay, now how am I going to make sure that if I use my module, it's only going to look at my module's versions and not the other module's versions? So good news, Renovate can also deal with that, and it's by providing it with a custom versioning. So by default, it's using a versioning scheme called regex coerced. I don't know how to pronounce it properly, which means it's a bit looser than regex. It supports 1.0.0 and also it supports 1.1, and it supports a v prefix or without v prefix. So it's a bit looser than regex, just so that you don't go mad. But basically, you can bring your own versioning here, and this is the regex that you can use for the Terraform use case, where you are saying there's a compatibility part. This is like code word for this is separate from the others. So this is how you group the various different dependencies with this compatibility part. And then you say major, minor patch, where you do the capture groups to patch the different parts of the version. And then this technically results in a pull request like this one, where it says, it's a bit ugly because then the change actually involves the entire tag, not just the version. But you also have the release notes. I didn't make release notes, sorry. This is just a demo. And then you can see like it patched my Terraform code to use the new tag. How many of you are using Terraform like this and not pulling Terraform modules from the Terraform registry? Hands up if you are using the Terraform registry. Nobody. Hands up if you are using Git to manage your to consume your Terraform modules. Nobody's using Terraform. What? What are you using? Crossplane? Lyft? That's an internal. So anyway, I think this is it. So I think I managed to show a couple of interesting examples. So I'm gonna stop the share. Do we have any questions?
Hi. I assume you can you configure any kind of verifications with SHAs and shit like that?
You mean so that it also patches the SHA?
Yeah, and
Yes.
make sure that it's the same.
Yes. Oh, let me show an example for that, because I forgot I have an example for that too. not in this repo. So I recently did this because there was a security incident a couple of weeks ago. Oh, not on the screen. So I did this because there was a security incident a couple of weeks ago with GitHub Actions, where the compromise was they repushed the tag. So if anybody who didn't have the hash pinned and used that action was impacted. Thankfully, it was not a super serious issue, but it did impact like a couple of, probably 100 repos. So in this case, like with the GitHub Actions manager that is aware of the GitHub Actions syntax, you just had to flip a flag that says pin to the hashes. And the nice thing is you can see it pins to the hash, and then this is what dependable doesn't do. It also puts the actual version that it pinned when at the time of the pinning into a comment, so that you still have an idea of, okay, which version I am at. Because, and this is why GitHub Actions is a bit shit, is that it doesn't have a separate log file to log your actions, so that the code is kept clean. So you have to make this dirty code with pinning the hash. And then you can do the same thing with Docker files, where you're with Helm values files. So like when you are patching a Helm values file with Renovate, you can use the usual like version at SHA format to also pin the hash. So yeah, it's fully supported. And even when you're writing the manager, like if you are doing a custom manager, you can have it also in a custom manager to also capture the hash if there is one. Obviously, it depends on what the data source is. Not all data sources have hashes. Okay, any other question?
So you showed a few examples on how to configure this. We also use Renovate with custom managers, and only for a dozen repos, it became a little bit out of hand to synchronize the configuration, to reuse them between repos. Can you show some or share some ideas around how to configure these at scale, assuming you have a lot more repos and a lot of them share the same characteristics?
Are you already using the configuration sharing, or?
Yeah, we already use
Okay.
it, or trying to figure out how to use it.
So what I started using was try to capture the generic parts. Like, and I'm not gonna say anything magic here. Like try to capture the generic parts, put that into the common config, and then I think it's not a problem if some custom config lands in the repos, as long as you realize that, oh, this could be used by others. One interesting thing that I experienced was around the custom managers, where you cannot just pick a single manager from the common configuration. So what I was doing like if it's custom managers, I'm not gonna have a single common config, but I'm gonna consume optional ones. So there's a default that applies to everything, and if I need one of the custom managers, there's a second one that I'm including, just to show what I'm talking about to others. So it's this one where you say there's an organization global common renovate config, and then it is just pinning to a release with a hash, but you can also include specific configuration files. Now, this is the default JSON that you include. If you don't name it, it's gonna pick the default JSON at the repo root. But you can have like multiple. That's why it's a list. Like you can have a multiple extends sources, and technically that's how I do it. So there's the common one, and the optional ones I don't include in the common, but include it explicitly, so that it's not that gnarly. And the other thing that's important, which I managed to optimize with, is to explicitly declare which managers are applied to a repo, because by default, the file path matches are going to be evaluated for all managers. So if you only want to patch Docker, you can say, okay, I just want Docker patched, and then it's going to be speeding up the process a bit. And then the other one is sometimes it makes sense to run separate renovate instances, because if you like run a single renovate instance on like 10 repos or 20 repos that are very big, then it can take to like 30 minutes to an hour to fetch all of the data sources, and because you also have to think about rate limits when it reaches out to GitHub. You don't want to overwhelm GitHub with your, you don't want to hit the rate limit basically. So that's why it might take a long time. So it's easier to like cut it up. Another thing, it has support for caching some parts of the lookups. So you can it can utilize Redis or Valkey to store some of the release lookups. So like if there's a release that it includes in a pull request, it can cache it in Redis and it's not gonna fetch it again, and that reduces the runtime a bit.
Final question? Okay, if not, well, of course. It can cache it unless it's they redeploy the same version and then the hash gonna collide.
Just an obvious one. I assume it can group.
Yes, it can group. Like this is one of the major features. For example, you have tools. I cannot immediately come up with a good example. Angular comes to mind, where it's a cluster release. It has like, I don't know, 20 different NPM packages with the exact same version. I don't want to have 20 pull requests for every single Angular patching. So you can have various different methods to group the version bumps into a single pull request. Like one is like, okay, all of the Angular version bumps go into a single pull request, but then there's also a way to say, I'm actually gonna group all of the updates to a folder into a pull request, and then you say group by the folder name or group by the entire path, repo path, and it usually boils down to branch names. That's the secret. So if it's going into a unique branch name, it's gonna be a unique pull request, and essentially you're trying to manipulate what the branch name is gonna be, and if it's the same, it's gonna go into the same pull request. There's a secret, and then there's a thin abstraction on top that says group.
Nice, cool. Zoli, it's been a pleasure. Thank you very much for spending the time preparing this presentation. Very well done.
Thank you.
So we kind of reached the final, like, thank you words. Even though the presentation are over, the event is not yet. The pizza just arrived. So thank you very much again for Cloudera for hosting us, providing the food and the place for discussions. Please, if you can, stay around. I think the DevOps community is quite friendly, so you can just randomly talk to any guys. They're not gonna say no or turn their back to you. Okay, maybe there are some people who might do that. Anyways, so thanks again for coming here. It's been a pleasure, and hope you're gonna enjoy the rest of the networking session. So thanks.